Here we go. This is a little application, write this down, of exponential growth and decay. Okay? It's your exponential function, e. It's a little application. In what's known as the sciences, in the consumer math courses and in the biologies, some things grow or decay according to an exponential function. And the generic function that we're going to use, or that these examples will be modeled after, is called y equals CE to the KT. Say that, please. Y equals CE to the KT. Say it. Y equals CE to the KT. So here's the given assumption. I'm telling you that these problems you're about to do are modeled by this exponential function e. C is just a constant. It's a number in front, like 3, 5, 1,000, whatever. T will stand for time. That will be like our x value. And time will be in whatever the context of the problem is, preferably years. And k is another constant. But the value of k is going to determine whether it's a growth or a decay. What do you think would be meant by a growth? What do you think E would be doing?
It would be going up.
It would be rising. And we know that, y equals e to the x, its general form is this, because the coefficient in front of x is 1. So for us, as time increases and the y values increase, we call that a growth, because the y is the amount of something is increasing. If the number in front of the x, which again we call as k right here, is negative, then it's not going to be a growth, it will be a what? Because you know that the graph of e to the negative x falls from left to right. So as time goes on, which is nothing more than your x variable, the amount is decreasing. That's all. I mean, you'll solve it the same way, whether it's a growth or a decay. But some things will be growing and some things will be decaying. All right. So the first kind of application we're going to talk about is called a radioactive isotope having a half-life. So let's just take some inventory. We have a radioactive, actually I think I have this in your notes class. If you go here to notes, I have this pre-written out for you already. Yes, it's example 4. It's right before assignment 40. So go to assignment 40 and the example page right before it. Did you find it? It's not that one, it's right here. So it's example 4. Let's start with that one. Did you find it? Not right here. Right here. Yeah. Example 4, right before page. Example 4. Okay? So let's read that out loud. Everyone, let's go. Radium decays exponentially and has a half-life of approximately 1,600 years. That is, given any quantity, 1/2 of it will disintegrate in 1,600 years. If 50 milligrams of radium is initially present, then when will the remaining amount be 20 grams? We're going to work with this in a couple of ways. So what we have is half-life. Half-life means how long it takes for half the amount you started with to be remaining. So if you started with 50 grams, half of 50 is what then? 20. So if I tell you the half-life is 1,600 years, that means in 1,600 years you'll have half of what you started with. Agreed? So that's what's meant by half-life. How long it takes for half the amount you started with to be gone or to decay. Are you with me? So let's take inventory that in this problem, the half-life is 1,600 years. Agreed? How much did we start with, everyone? We're starting with 50 grams. So we start with 50 grams. So initially, y equals 50 grams. All right. We're going to solve this problem in like 3 levels or 3 major steps, and it's always the same. The first step is we're going to let t be 0, meaning at time t equals 0 years. We started with 50 grams. So that means y equals 50. Okay, does that make sense to you? Because when you're first given the amount, you can call that time 0, and you have 50 grams. That's y. So put a line, and you're always using the equation CE to the KT. And in the first step, you're going to find C. So in the very first step, you're going to find C. You let y be 50 because that's what you started with. CE. Now what's T here, everyone? T is what? And what's 0 times K? So then C equals what then? What does C equal? 50, right? And that's easy. Either the 0 is 1, so C is 50. Next step, you are going to find your constant K. So the first step is to find C, the coefficient. The next step is always finding the value of K. So, in the next step, we know that when time equals 1,600 years, the half-life, we have how much remaining at that time? 25 grams, because that's half of 50. And the half-life is 1,600 years, so we'll have 25 grams remaining in 1,600 years. Is that clear, everyone? You still use y equals CE to the KT. Now we continue under it, but I don't have enough room. So y now in this step is 25. C is 50. E and K is, we don't know, we're finding it, and T is 1,600. So I'll put that in front. And all you really end up doing in this is the most work. It's pre-calculus. You're just solving for K, T, or Y. That's all you're doing. There's no calculus, there's no limit, there's no derivative, nothing. It's nothing more than an application of exponential growth and derivative. So I'm going to solve for K right here. How would I do that first? What would I do? Same as if it was X. What would I do? I'm solving this equation for K. What would I do? Jacob, what would I do?
Divide by 50.
Yeah, divide by 50, right? It's just like we solved these last year. And what's 25 over 50? And it will always become 1/2 in this kind of problem. How do I undo E? ln both sides. ln it. So I'll take the ln of both sides, and I'll get ln of 0.5 equals 1,600K. Divide by what? And we don't want a decimal for that. We want to keep it exact. And if you recall, the natural log of 0.5 is negative. Because here's your graph of natural log. 1, 0. Between 0 and 1, the natural log function is negative. From x greater than 1, the natural log function is positive. So k is actually a negative value, which means we're dealing with a decay, because we're ending up with fewer than what we started with. So k is this constant, the natural log of 0.5 divided by 1,600. So once again, the first step we found C, the second step we find K, it doesn't change. And the third step, we have two options in the third step. We may either find Y, the amount, or find t, the time. In this one, it said, when it's time, when will remaining amount be 20 grams? So that means here, we want to find t when y is what, everyone? 20 what? And what equation will we use? Y equals what? But we're going to use the values we've obtained. So I may have to, I'm going to rewrite this because I have to, I need more room here. So y equals CE to the KT. And I want to solve for t when y is what did we say? Did I say 20, right? So this becomes a what? What is C? What is C, did you learn? You have to be real neat with your work here, because when you deal with exponential functions, when the powers are a fraction, you have to be real neat with your work here. Otherwise, you won't know what's a fraction, where k is at, you're going to be lost. So be real neat with your work. So it's going to be e to the power of, k is the natural log of 0.5 divided by 1600 times what? Everyone. Times t, correct? And sometimes it's better if we put that out in front. So I'm going to divide by what on both sides here? 50. So then I'm going to get 2 over 5 equals e. And it depends how you want. That's okay right there. Natural log of 0.5 over what? 1600 what? T. Agreed? Yes? Now, we can't cross these out. It's e to the ln of this stuff. This is where you have to be real careful. So watch. Real meticulous with our work. Where can I do this? I'm going to put it up here. Is that okay? Can you see a little better? So watch. I got to solve for t. I can make life very easy for myself by being clever. Putting the t in front, which is fair. Do you agree? And then what happens is, this is a coefficient in front of the ln, which means I can bring this back up on top and make it 2 over 5 e to the natural log of 0.5 to the power of t over 1600. Do you see that? What am I doing with this t over 1600? Bringing it where? Back on top. It's just like this. If you had 1/2 the natural log of x, what could you do with that 1/2? Bring it back where? On top. You can't use the inverse property until it's exactly e to the natural log of some stuff. Now it's exactly e to the natural log of 0.5 to this power. Now by inverses, they undo each other to leave me with what? 2 over 5 equals 0.5 to the power of what? Agreed? Well, now, to solve for t, it's an exponential equation. Now again, I don't like this way always, but I like it like this better. I'm going to do what to both sides? No, you can't divide by 0.5. It's an exponential function. It's 0.5 to this power. I'm going to natural log both sides. If you had e to the t equals 5, what would you do? ln both sides. So I'm going to natural log both sides and get the natural log of 2 over 5 equals the natural log of 0.5 to the t over what? And then now what happens? What can I do with this power now? So it's the natural log of 2 over 5 equals t over 1600 times the natural log of 0.5. And now it's very easy. Cross multiply and make this 1600 on this side, and then divide by the natural log of what? 0.5. I'm running out of room, so there is my time. Okay? How would we figure that out? On the calculator, of course. You guys can use any scientific one, but because I didn't give you those this year, you can keep it as such. You can keep that answer as such. You don't need to solve for it. But if you're curious to know what that time is, you just take 1600 times it by the natural log of 2 divided by 5, and you divide that by the natural log of 0.5, and we get the time to be 2,115 years. Because it makes sense. The half-life was what? 100 years, right? And we're talking about when will how much be remaining. I think it's 20, right? So we should have a little more than that, correct? We're talking about 20 grams and half of 20. What did we start with again? I forget. 50, right? So then in 1,600 years, we would have what? 25, right? So we have a little more than 20, less than 25. Okay. So then now what else is there? Okay, let's do another example. Okay. As you go through them, it's not that hard. That's the most tedious part. Then that's not calculus. It's just all algebra. So let's go to assignment 40. Okay. And let's take a look at, say, I don't know, let's do, what do you want to do here? Let's take a look at number 2. A population grows exponentially. So an assignment, let's do this one then. An assignment 40, number 2. A population grows exponentially. So that means in these problems, it's CE to the KT is the equation. During the first 10 minutes of observation, the population grows from 1,000 to 5,000. When will the population be 6,000? So you have to do 3 steps. The first one is to find C. That's your very first step. And you always start with that being what? Time is what there? 0. So time is 0. What's the amount when time is 0? How much did you start with? 1,000. So why is 1,000? You can continue if you want. Now the second tier, it says in what? 10 minutes. So that means 10 minutes later. T is what? 10. What's the amount? 5,000. Agreed. And finally, the question in the third tier says what? When means time. The population be what? Yes. Find C, find K, and the last part is eventually find T. So go ahead, find me C first to start. Remember, you're always using, at each step, you're using CE to the KT. So what did C come out to be, everyone? Okay, so then I write down y equals CE to the KT. You do have to admit, being neat with your words really matters because you won't know what's an exponent or what's a base. and where the fractions belong. So be real neat with your work, especially when exponentials have a fractional power. They get very messy. So y is 1,000, and t is 0. E to the 0 is 1. So what's c, everyone? Done. Okay? So c is 1,000. Find decay now. Go to the second step and find decay. Okay, so guys, look up here. You always write down, I guess I'll go over here. This board is small. So I have c e to the kt. I'm going to find k, agreed. And what is y in this case? It's not a half-life problem. Do you understand that? I think we actually have a growth in this one, don't we? Because as time increases, the amounts are increasing. So this time we have a growth. Okay? But still, it's the same steps. So you get 5,000, c is 1,000. E to the 10 what? Divide by what? And get what? How do you undo E, provided it's set up? And divide by what? And this is a positive value. Why is this a positive value? Because the natural log of 5 is positive. It's greater than 1, right? The natural log of 1 is 0. So it is a positive value, so it's a growth. Good so far? All right. And the last step is easy. It's just a little tedious when you have to solve for t, because you have the power. So let's be real careful. So again, you write down y equals ce to the what? And what is y this time? And c is 1,000. E. And now we have, this is where you have to be real careful, 1/10 natural log of 5 times t. Now this is where students can make things more difficult for themselves, so watch up here. You see how you have this t? Okay? These, you can't use the inverse property yet. Not until this comes back on top of the ln. It has to be exactly e to the natural log, not e to this times natural log. So if you put the t in front, you get t over what? 10, correct? Right? And what am I going to do with this now? So we get, these thousands divide out. I think we all agree with that. So we get 6 equals e to the natural log of 5 to the what power? T over what? Are we good at that? So I put the t back in front, bring it back up on the ln. These now undo each other by the inverse property. But guess what I have to do now to get that power down? ln it. So it's going to be the ln of 6 equals the ln of 5 to the t over what? And then what can I do with that t over 10 power? Then cross what? Hello? So it's 10 times the natural log of 6 equals t times the natural log of 5. Divide by natural log of what, everyone? And I'll accept this as the answer. So t would be 10 times the natural log of 6 over the natural log of 5. And if you're curious about the time, it would be about 11.133 minutes. Okay? Yes? Now, if we were given time Suppose in 30 minutes, what would be the amount be? Look back here then. Suppose that was the question. What's the amount in 30 minutes? You just replace t with 30. You have the value of k. You have the value of c. Just simplify and you'll have what y is. There's nothing to really solve because all the variables are on this side. That, y is this. And you're replacing t with 30, k with that value. You already have c. There's nothing really to solve. It's already solved for y. The greatest work is when you have to solve for t. But the biggest thing is being really meticulous with your work. So look over here. If you have e to say t over 1300 times the natural log of 0.5, what would you do? Bring this back on top and make it t over what? Then it would become what? 0.5 the t over what? 1300 power, then you would natural log both sides. Okay? Alright, so here's your homework. You can rewatch the video if you need to.